Hello everyone. We're talking about the quadratic formula, finally. Okay, this is the last piece of our factoring and solving. And we don't have to factor here. We're just going to go straight to solving because that's what the quadratic formula does. And we're going to talk about the components of it um, and how it's useful, right? So when we're looking at the quadratic formula, we need our function in standard form. So we have ax squared plus bx plus c. So some numbers there, any of them could be 0. So, we might not have a bx, we might not have a c. But generally, if that's true, then there are better ways to solve it, right? We wouldn't use the quadratic formula. We would use something like factoring or um, taking a square root, okay? And what we're finding here is when y is 0, what is x? We want to know what x is. Because a, b, and c are numbers. They're going to be numbers. We just haven't filled them in yet through our standard form. And we want to figure out what value of x makes it 0, right? Because we're looking at the graph and we're saying, okay, what's that point? And what's that point? Do those points exist? Okay. Now I want you to think back to last chapter, chapter 2, where we talked about the axis of symmetry, which existed at negative b over 2a, right? And we use that to find the vertex. And so I want to think about this in terms of, well, okay, if we have negative b over 2a, that's where this is. That's what this x value is. We're going to add a bit to go to this side to find the right one. And we're going to subtract a bit to find the left one. And how much that is depends on a bunch of things. Depends on these three numbers. So here is the quadratic formula. And I want you to keep this negative b over 2a in mind. So x equals negative b. We just saw that. Plus or minus. So we're going to add a bit to go to the right, and we're going to subtract a bit to go to the left. We talked about plus or minus last week. The square root of, oh boy, I should get this right the first time. B squared minus 4ac all over 2a. Okay. So here we have negative b over 2a plus or minus this piece, the square root of b squared minus 4a, also divided by 2a. We've just combined it into combined the two fractions into a single fraction. And we're not going to prove how we got to this formula. I mean, we may when we're together in class. I don't think that that's the most important thing. But we have some pieces, right? This negative b over 2a is where the vertex is. And then we're going to add and subtract a little bit this much to find the other pieces. Now that piece has a special name. The part inside the square root is the discriminant. The discriminant. This is a vocabulary word that's going to be important. The discriminant, this number, once we've squared b and subtracted 4ac, once we've simplified this, it's going to be a couple things. It could be 0. So let's just say, okay, so the discriminant, b squared minus 4ac, you can't really tell that orange is different than red, but let's say it equals 0. Well, what does that mean? that means that this square root is 0. We're left with nothing. And so x is just negative b over 2a. This means that there's only one solution. Means one solution. And so if we're looking at just like a little picture of our graph, it's going to meet at just the vertex. One solution. So if the discriminant is 0, then we have one solution. Well, what other possibilities do we have for b squared minus 4ac? Well, b squared could be the biggest number, and then you'd have a positive number, right? If we subtract minus 4ac and it's still positive, then we get a real number. So if b squared minus 4ac is bigger than 0, then there are two solutions. And the graph would cross twice, right? Because then we'll take that square root and we'll add and subtract a little bit. And so we get two values for x. We'll do some examples for these, but I'm just talking in theory. And so if that's a positive number, that square root's a positive number, then we have two solutions, two real solutions. And now this is why we talked about imaginary numbers the other day, because there's another possibility. Switch colors again. What if it's negative? What if it's negative? Right, that means smaller than 0, right? This number has to be smaller than 0, so it's going to be a negative number. Could be I mean, these could be fractions here, but we're talking about positive and negative when we mean less than 0. So this means that the 4ac is bigger than the b squared. And so we have a negative number, which means we have a negative square root, which means that we have imaginary solutions. They're imaginary. They're not real. They're imaginary solutions because our solutions are where the graph crosses the x-axis, which means that this imaginary solution, well, it never crosses the x-axis. So the discriminant, the part inside the square root, right? It's this piece in here. Controls how many solutions there are. So all three numbers are involved here, right? B squared and A and C. It takes all three of those numbers to control like how many solutions there are, because those control where the graph is. But you can think, all right, if we don't have a b value, if b is 0, if this doesn't exist, then we have minus 4ac, which means if either of these numbers are positive, we're going to have imaginary solutions. Like x squared plus 9 is going to have imaginary solutions because you're going to get a negative number in there. So if b is 0, then one of these has to be negative for there to be two real solutions. Or, b could not be 0, and then this just needs to be smaller than the b value because we're subtracting. Okay. This strategy, this idea of just looking at the variables and thinking about, well, if this number is big and this number is small, is a really important form of mathematical thinking. Okay. And there are whole fields that use this, that simplify big ideas by just kind of ignoring parameters because, well, in this case, the number is really big. Anyway, so we're going to use the quadratic formula to find 1, 2, or imaginary solutions for x. In no case where there'll be no value. It'll just be imaginary. Okay, so let's do some examples then. And these aren't always going to be pretty, which is why we also practiced simplifying square roots. So they don't need to be pretty. Sometimes it'll simplify really nicely. If it simplified really nicely, it's probable that we could have used a different method to find the solutions. And we'll do some of those where it's like, well, you could factor this a lot easier, right? This is most useful for things that are not factorable or things that are imaginary. So those are the kind of the best uses for quadratic formula. So we're going to do kind of like the harder example first. Plus 3, sure. We're just using random numbers because that's what we need to be able to do. That's what the quadratic formula is most useful for. I have no idea if this is factorable. It's probably not. Oh, it actually might be. Well, we'll simplify it and we'll see. So first thing we do is we just list out A, B, and C. We always do this if it's in standard form and we want to find the solutions. So we're finding solutions. Okay, so A, B, and C. A is 2, B is -7, C is 3. And my formula is x is going to equal negative b plus or minus the square root of b squared minus 4ac. And all of it gets divided by 2 times a. So now we're just going to substitute in the values. I'm just going to plug these numbers into where the letters are. So x equals -7, so +7, plus or minus the square root of -7 squared minus 4 times 2 times 3, right? 2 because a is 2, 3 because c is 3. All of that divided by 2 times 2. And then we simplify. So we just got to do order of operations to combine things and multiply things out. So 7 plus or minus the square root of -7 squared is 49. Minus 8 times 3 is 24, or 6 times 4, 24. All of that gets divided by 4. Probably going to run out of room, but this turns into 25. So it is factorable. And I know that because this happens to work out quite nicely. So 49 minus 24 gives us 25 all over 4. Now this, sometimes our answer is just going to look right like this because this square root isn't going to simplify, and so we just leave it. And we say, okay, that's 2 numbers that we've written kind of as one number. And we are not going to simplify the equation anymore because the square root won't simplify. But in this case, it does simplify. The square root of 25 is 5, and so we get 7 plus or minus 5 over 4. So this gives us two problems that we need to simplify. And we did this before when we were looking at, oh, I am blanking very hard. What did we use plus or minus for? Square roots. When we took square roots of things, we did plus or minus. And so we need to do 7 plus 5 over 4. And we need to do 7 minus 5 over 4. Right, so the plus of the plus or minus is one problem, and the minus of the plus or minus is another problem. And so we get 12 over 4 equals 12 over 4, sorry, equals 3. And 2 over 4 is a half. And so my solutions are x equals 3 and a half. This is the answer. Now for this problem, you can for sure factor it, and that might be faster. You would use A, B, and C here to do the x in the box, and that would probably be faster than the quadratic formula, but the quadratic formula is best when it's not factorable. So in this case, the random numbers I picked betrayed me, but that's okay. Okay, so what that means is we found the solutions for x. We found, okay, one of the roots is at 3, 0, and the other root is at 1/2, 0. The quadratic formula always will find the roots. You know, factoring, sometimes you can't factor. Sometimes it's hard to factor. Taking square roots, sometimes you can't take square roots. Sometimes it's hard. This will always work. So on the test, if this is the only way that you solve anything, that's fine. Just realize, you know, it's tedious. You've got to plug all the stuff in. Okay? So let's do some more examples. We're still going to solve. I didn't write it, but I probably should. But we're going to solve. Let's see, what numbers do we want? Excuse me. 3x squared minus 2x. Yeah, we'll do plus. And then we'll do plus here too. Let's see. Sure. Yeah, that works. Okay. So we list out A, B, and C, and we're going to solve. So A is 3, B is 2, C is 1. This might seem like Mr. Martin just picked really weird numbers, but it'll work out. Kind of. So then our formula is x equals negative b plus or minus the square root over b squared minus 4ac all over 2a. Something you can do is just calculate b squared minus 4ac, right? So 2 squared minus 4 times 3 times 1. So this is 4 minus 12, which is negative 8. Which means, therefore, these 3 dots mean therefore, we're going to have imaginary solutions because this number is negative. The discriminant is negative. So because the discriminant is negative, we're going to have imaginary solutions. That's okay. That means the graph, if I was to graph this, is above the x-axis and never touches it. You know, sometimes it could be below the x-axis and never touch it, but it's the same thing. So x equals negative 2 plus or minus the square root of this, what we already did. I'm going to rewrite this like we normally would. Minus 4 times 3 times 1 all over 2 times 3. But we already know that this simplifies to negative 8, so I'm just, because we did the math over here, so I'm just going to rewrite it as negative 8. Negative 2 plus or minus the square root of negative 8 over 6. Now, what's the square root of 8? And what do we do when there's a negative? Well, we talked about this earlier this week when we were doing simplifying radicals and imaginary numbers, but we can simplify this square root of 8 into 4 and 2, and so the square root of 4 is 2, and then the 2 stays behind. So this equals negative 2 plus or minus a 2, a square root of 2, an I, because we got rid of the negative inside the square root, so there's an I, and that gets all divided by 6. Now I would accept this as the answer. So that's fine. But we can actually simplify this further by dividing. Right? So it's being divided by 6. Those numbers all have a 2 in common, right? We have a 2, we have a 2, not this 2, and then there's a 2 inside this 6. So this also equals negative 1 plus or minus the square root of 2i divided by 3. And so this is a better answer. Both are acceptable. We've simplified the square root, but we can also simplify this fraction further. And so this is the better answer. And that's just the answer. You know, you could plug that in your calculator a bit. It's got that imaginary number, so trying to graph it isn't going to do you any good. But we have a complex number on top, and then we're dividing by a number, and that's it. You just leave it like that. Okay. I'm trying to think of any other cases that would matter. If you get 0 inside of your square root, it's just 0. And so that's okay. Maybe we should do an example like that. I'd have to think. Yeah, that's fine. So I think 2x. Yeah, 2x squared plus 4x plus 2. I think that works. Yeah. So we list out A, B, and C. They're easy because, you know, they repeat a little bit. Then we plug that into our formula. So x equals, I'm not going to write out the whole formula this time. I'm just going to plug everything in. So negative b plus or minus the square root of b squared minus 4 times 2, which is also another 16, all over 2a, which is a 4. So in this, the 16 minus 16 cancels out, and plus or minus 0 just means that x equals negative 4 over 4, which is negative 1. And so our vertex is our root at negative 1 comma 0. Okay. I think that's it as far as the quadratic formula goes. We're going to, we're going to do more practice problems, but a lot of your answers are going to look like this. That's okay. They won't always have an I. Sometimes it's just a complicated number that we leave as a plus or minus. Sometimes we can simplify that plus or minus, but if it's a square root, you just leave it. Because what's 1 plus the square root of 2? Well, then you'd have to change it to a decimal, and we don't want to change our square roots into decimals. We want to leave them in the most accurate form. Okay, so again, the discriminant of the quadratic formula controls what kind of solutions there are. We talked about those already a little bit, not just today, but before. And the vertex is at negative b over 2a, and so we're adding and subtracting this amount to find out where the roots are, because the roots are equidistant from the vertex to the left and to the right. And the quadratic formula is x is some number. This is just a number, where that number uses a, b, and c from standard form to do negative b plus or minus the square root of b squared minus 4ac. Everything divided by 2a. And when you simplify that, you find out where the roots are. Okay? So that's the basics of the quadratic formula, and now you probably have something to do with it.